How do earthquakes and volcanoes occur? Why are the continents far away from each other? How were mountains formed? There were a lot of unanswered questions that were finally answered by the theory of plate tectonics. However, there were many theories that led to plate tectonics, such as continental drift. This theory is the best explanation we have for those questions till now. Not only that, but it relied on empirical evidence such as fossil distribution and study of magnetic patterns. The first one who wanted to understand how the Earth moves was Charles Hapgood. He noticed the correspondence in shape between certain continents. Hapgood wrote a book named Earth's Shifting Crust, a key to some problems of Earth science. The idea was later dismissed when geologists K. E. Castor and J. Siemens had done fieldworks on both sides of the Atlantic, and there were no such similarities that existed as they said. An amateur American geologist named Frank Bursley Taylor later contradicted the theory of Hapgood in 1908. He was struck by the similarity between the facing coastlines of Africa and South America. He then started to develop an idea that the Earth had once slid around. He also said that the crunching together of continents could have thrust up the world's mountain chains. However, this theory was considered too crackpot because it lacked evidence. Alfred Wegener, who was a meteorologist at the University of Marburg, later picked up Taylor's idea. He wondered how similar animal fossils were found on opposite sides of the oceans, which were too wide to swim in. Also, he wondered how the identical snails turn up in Scandinavia and New England. He then started to develop a theory that the world's continent had once existed as a single mass called Pangaea, where the flora and fauna were able to mingle. His theory was accepted when he made a revised and expanded edition, and everyone agreed that continents moved, but up and down in a process called isostasy. Another theory that also explains the composition of the Earth was the baked apple theory. This theory states that when the molten Earth had cooled, it was wrinkled, creating ocean basins and mountains. Some people said that the heat of the Earth couldn't allow cooling, so this theory was ignored. Scientists later on tried to dismiss Wegener's idea. They made another theory that discussed the existence of ancient land bridges through which animals were able to travel from one landmass to another. So, whenever fossil distribution couldn't be explained, land bridges were drawn between continents to explain how those organisms travel from one continent to another. Some geologists used land bridges to prove how Hyperion was found to have lived in France and Florida at the same time. However, this theory didn't explain many things, as no fossils were found on the path between continents. Another geologist named Arthur Holmes said that the convection currents were powerful enough to slide the continents around the surface. Holmes suggested that the radioactive warming could produce convection currents within the Earth that generates an internal zone of slippage, which could account for the displacement of continental land masses. His theory, continental drift, was published in 1944 in his textbook Principles of Physical Geology, which formed the basics of theory that prevails today. In 1962, Harry Haas, who is a geologist, published his hypothesis of sea floor spreading. He used the mid-ocean's ridges and trenches to explain how the ocean floor was formed. Haas hypothesizes that mid-ocean ridges marked places where magma rose close to the surface. He also suggested that the extrusion of magma at ridges pushes ocean floor away like conveyor belt. The floor is then pushed below the continents in subduction zones. In 1906, Bernard Bromhes discovered that the magnetic field of the Earth reverses itself from time to time. The history of those reversals is permanently fixed at the time of their birth. By studying iron ores, scientists were able to know the direction of the magnetic poles at the time of the ore's creation. This led to the discovery that Europe's magnetic patterns and Americans' patterns fit together exactly. Using the magnetic studies, they discovered that the ocean floor was spreading in the way Hess said it does. Not only that, but the continents were in motion too. After all these theories and scientific studies, scientists agreed that the Earth was a mosaic of interconnected segments that move, creating the planet's surface behavior. After scientists discovered that the whole crust was in motion, not the continents only, the name continental drift was discarded. At first, the people called it crustal blocks and paving stones, until it was called plate tectonics. Those segments in motion were called plates. Plates vary in their size and activity. There are 8 major plates in the Earth. This theory explained the surface dynamics of Earth and how the continents move and will move. Not everyone accepted this new theory, as old ideas die hard and some scientists try to falsify it. All these theories were made to know the cause of the movement of the continents. Some scientists came up with ideas that were in a way corrected but weren't complete. But after adding all the results of these theories together, we came to reason of the movement of the Earth, which is plate tectonics. It's a fact today, and no one was able to discard it, because it explained many things that other theories couldn't. It's a good example of scientific theory, because any scientist could test it and try to falsify it.